afternoon. Good Good afternoon, guys. I think from morning you have been hearing about all about the data, the real-time BI, etc., everything. This is the time, I think in 25 minutes, you are going to hear about how those things are done. I'm a technologist. Basically, my profession is to enable whatever all these guys are talking about, right? So one of the things I'm going to touch base upon is the real-time analytics, how we are built, how it is there in the industry, what it constitutes. This is going to be a tech talk. It's not going to be a business talk for you guys. So moving on, I'm sure a lot of you would have already understood about the big data. But how many of you are using real-time data or the near real-time data? Show of hands, please. Anybody understand? Okay, a couple of them. Good. So I'm not going to touch base upon the big data part of it because I think a lot of you understand. You are in the summit. You understand the big data part of it. But what constitutes a real-time data? Why it is important right now? Correct? Some of the panelists during the discussion, they touched upon some of the activities they are doing it. One of them, like they were talking about the patient records going in real time, or the telecom use case they were talking about where fraud calls are happening. Basically, the same number in multiple places, the calls are happening. How can you find out about those things? These are some of the use cases what you see in the real-time data. You need to act upon an event in real time or a near real time, right? So by definition, what you can see is whenever we talk about in the industry, real time means it is the in-flight data which is coming in, and you need to make a sense of the data as it lands into your system, right? It could be that one of the panelists talking about the map data, the traffic part of it. How it happens actually? It happens because of you only, who are on the part of the traffic. All your smartphones, which are there, is sending the signal. That's how Google knows about, okay, if there is a concentration of the mobile phone, it means that there is a traffic congestion which is going to happen. That's how you are getting back. That's an instantaneous data which is happening, right? So by definition, this is how you can say that this is the real-time data, the in-flight data where you are making informed decisions on top of the data which is coming in. So it's another misnomer with the industry is that although there is call it as a real-time data, but it is not exactly all the applications are in real time. It is the near real time. That is what they meant is the low latency takes for a decision making or an event, a response to an event. That's what it means about. Okay. So having said that, what are the characteristics of this particular real time, or you can hear another word called stream processing as well. What exactly it happens? We talked about IoTs or a lot of discussion about doing real-time BI, those parts of it. What exactly it means, right? See, some of the characteristics of a system are as the data is coming, you need to work upon it. That is the first characteristic of a particular real-time streaming system. We will go into the details. I'm not going to go into the technical parts of it, but at least the architecture part of it, I'll go into details of that as well. And another characteristic of that particular system, you should be able to do a query. At present, you are all conversant with, whenever you do an analytics, you are doing a query on a particular RDBMS or on a particular data source. Here, when you are building a real-time store, you should have the ability to do a query. The industry term, it is called CQL, that is a continuous query language, which is now being built across by the product as well, like your Oracle right now supports the SQL part, okay? So these things are the newer technologies which are coming in to support stream processing. I think I'll give you a couple of our own, my own work, where I worked in a couple of industries. The examples where we have used the real-time streaming system, and you will appreciate the fact that these are all a game-changing kind of a use cases that is futuristic. Not many industries have adopted it, but there is already some of the industries like fintech and all, they are moving in that particular direction because that is the new things which are happening. Third one, as we go on building on the streaming part of it, right, there are imperfections you have to handle it. Imperfections could be the failures, etc. that we will see. As this industry, as this technology evolves, there could be business critical applications which are coming in, right? Can you generate reliable results out of this particular streaming one? At present, as you can see, in the industry, there is still it has to evolve to that state, but already you are seeing is already we are seeing some of the applications which are already there in the market, which are dependent on this. You cannot afford to go down. All your IoT applications, for example, somebody talked about smart water, correct? That's a kind of a thing where I worked in a particular use case which talked about there were individual silos and the wastewater was getting collected in that. This is for a European client where the wastewater was getting collected. At a certain point, there is a signal which will be generated, and after that particular point, there will be a overflow which is going to happen. So you have a real-time event which is coming in, and a decision need to be made what we need to do about that particular event which is happening. That's a real-time use case scenario, right? That's a decision making we are talking about, and it needs to have predictable outcome as well. Like some of the analytics what we do, it's need to have it. Another thing, how many of you have heard about Lambda architecture? Okay, two of you. So let's hold on to this particular characteristics on the Lambda part of it as well. I think that's the industry, again, all of your analytics, what we are talking about, it is moving in that direction. You cannot get away with this particular one soon. There is another part which is very challenging for real-time streaming is the data guarantee. See, as the data is coming, when I talked about the one of this IoT example where the signals are coming in, what happens if the one signal is lost between your translation? You got the signal, but it didn't reach the final acting system. What happens there? Whether you can, is that your built-in mechanism in such a way that there are no data losses? Or what is that you are willing to invest in this particular system so that if there is a data loss, you have a fallback mechanisms, right? This is the same space. These are some of the challenges you will find it whenever we are building mission critical applications, right? Then another characteristic of this particular systems are you need to be able to scale. For example, the traffic system, when we talked about that particular one, what happens if there is a peak coming in and you are not able to handle it, right? If there is a condition which happened and there are multiple gridlocks happen and your system is not able to take care of it, right? So if you have not built your system in such a way that it can scale or it can handle this kind of a impulse data which is coming in, you will not able to handle those. Then you will be dropping the data, or you will not able to meet your own SLAs, right? The last one, I think it's a common one as a part of IoT as well as any streaming system. You need to be able to respond quickly to any particular event. That's another characteristic of a streaming, overall streaming application or a streaming processing, what you're going to build it. Right? So I want to move back to another one where I think sorry. Just give me a second. Yeah. So this is a by definition this what you call it as a streaming processing, right? So if you look at it, this the brown small round, it represents a particular event. Now, as the event are coming in your IoT cases, as the events are coming, it takes a little bit of processing time that represented by the blue square boxes, right? So that is the time it takes, and it sends the acknowledgement to a sending device or a sending system, it could be. In case of streaming as well, and if you're working on a particular event, that is the overall time, the data and the processing time before you send the acknowledgement. Why you are sending an acknowledgement? You are saying that you have received the data. That is the data guarantee part of it. That applies for particular IoT use case or streaming use case as well. Now, when we talk about real-time streaming data, one is the IoT part of it. I hope Internet of Things are clear to you guys. The second one is sometimes we adopt another technology. When we, like somebody mentioned Spark, we talk about micro-batching basically, where we collect some amount of data and then we process it. That is what is represented there as the 5 brown dots and the blue balls. That is the processing time it takes, and you send back the acknowledgement saying that, okay, have received a file, what you have given to me as a system to system, and say that I have received it, I have acknowledged, I'm sending you the acknowledgement. That is the part of overall micro-batch. Now come to the window part of it. This is something like when you want to do analytics part of it. So then you go for further batching basically, where you say from this particular window to this particular, it could be a time range where 10 to 10, I wanted to see that particular one. That is the window part of it. Okay. This is the basic premise of the stream processing. So I just wanted to give you guys a glimpse. Right. So these are the characteristics and some of the particular use case. I'll touch upon the challenges because I think as you are going to make decisions on some of the stream processing, you need to look at the imperfections, the stream imperfections, what we call. First one is how do you handle the data? As you have seen the processing part, for each of the event, it will take certain amount of time to process a particular event. As you go along, it may spike. As you increase the usage of it, you may have to increase it. And as you increase, the compute time might take more. Or if you bring in another use case, your overall compute might get harmed, correct? How will you handle the choice, the decision choice you will be making between the amount of time it takes to process a particular event versus the data guarantee or the data duplicate part of it, right? So this is one of the imperfection what you will see. Another is, let's say that the sensor itself is a having a problem, or a system is having a problem, and once it comes up, it will start pumping the data to me. That means it has come in an out of order. It is also important. For example, the industry I worked upon, if you are, let's say, calculating the total of a particular transactions which has happened, right? And if after I calculated and started showing the analytics part of it, I started getting the previous day one. Because of the one system was down, it started processing that and sending you all the data. How will you handle it? Those are the challenges you will start finding in the streaming, in any real-time data part of it. When we talk about like real-time BI, or you are talking about showing your own aggregate, the transactions, or the, let's say that classic case is like you have done a swipe, card swipe, and you are in your mobile, you want to see in your own wallet the total amount, total balance, or how much you have spent for that particular month. You want to show it, right? These are all the real-time use cases what we are working on. And just imagine if one of the transaction is lost, what will happen to your user experience, and what is the confidence level you will have on that particular bank or whoever the issuer is, right? Another thing is about the Lambda architecture part of it, where we talk about big data. That's the overall, that's the big data when we talk about. It is the data at rest most of the time, where you have batch processing going on. And here there is an interesting concept. I think a lot of industries are now moving into adopting to this particular one. Wherever there is analytics which are happening, you want to combine the real-time analytics as well as the data which you had within your own ecosystem, right? How do you combine those two? It could be the similar data, historical data, and as well as the data which is coming in at present, which is happening, and you want to show together. It could be a trend, like you can see that. Like for example, the best use case what we have showcased, and it won a lot of contracts for us, was we were showing, hey, this is your top 5 transactions which has happened with us, okay? And this is your current transaction which is happening. And it is also aggregating per day basis how much of this value, the transactions which are done for a particular customer. I'm talking about a B2B customer. Let's take it as a hotel, a particular hotel, where the customers are swiping the card, and I was able to show to the hotel, basically saying that, okay, this is your top 5 transaction till date, which could be in terms of lakhs or anything, but this is your date, today's total transactions which are happening. And I can also represent on a particular map, these are the transactions across your hotels which are happening. And let's say that there is a transaction which happens immediately, which is the topmost, or the total spend is much more, then your top 5 gets changed, because this one is the most recent one, it will go into the top 5, right? So you have both historical getting married with the real-time data which is coming in, and you can make a lot of insights out of it. As this one is talking about, this is about the process, which is another layer which is happening, and your regular batch process which is happening on the Hadoop and other your big data ecosystem, and you can marry this together and provide a meaningful insights. That is your Lambda architecture, right? Let's move on to the next one. I think this is another industry use case scenario which I worked on that I would like to present. I think during the panel discussion also, I think our Citibank guy was talking about a particular airline where you can see the offer. Here is the real-time use case scenario where, let's say that we have your all travel-related data. We know when you have booked your flight, and you have booked a cab with our own, let's say, the card. We will get that transaction. We know that you have reached the airport. That's you might have purchased something in the airport, maybe food, coffee or anything. That's another transaction you got. And we can tally between these two. We can correlate between these two events along with your travel, and we know when exactly your flight is supposed to start, right? And we know from our travel this one that flight has already left, but there is a transaction which has happened after your flight has gone. What that means? In this case, it could be that either you have missed a flight or there is a fraud transaction which has happened. You may want to block your card because there is a fraud transaction. Right? If it is, there are a couple of actions we can take actually. If you have missed a flight, right, we can rebook you in some other flight. You might need assistance in that regard, correct? That's a positive flow for you. And it could be that if it is a fraud transaction, we can identify that could be a fraud transaction. I can block your card, right? So this is one of the industry use cases which I have worked on. The second one which I had was, let's say I keep getting all these transactions. We are doing, a lot of our customers are using the particular card. We are getting all the transactions out. And let's say there is a catastrophic event which happened. It could be an earthquake, or it could be any natural or unnatural calamity which has happened there. I can know which are all my customers who are affected because of this particular event. Because of the real-time streaming, I can know who are all this, and I can inform your own, maybe you are on a business travel, I can inform your company or your company contact that, hey, please check on this particular guy because he was in this particular zone at this point of time, right? That's another kind of a use case that we have worked on. So I'll leave it at this one. This is something which can be, and I'll open up for any questions you might have on the real-time stream. Any questions? All right, thank you.
Thank you so much. Ladies and gentlemen, let's put our hands together for Mr. Shobhan Babu for that wonderful presentation. Thank you once again, sir. All right. Okay, so a few sleepy faces, I believe. I don't want to point fingers, but it's time for us to